of B, and A is given. So it means, what is the probability of B given that A has already occurred? And I'm going to have to figure out if there's two R's in that. Let's look, because you're looking right now. Occurred. Two R's. Haha. All right. Yeah, so A is given. That's like the past, and the first one is what you're trying to find right now. Okay, so example 6. Let's say that two cards are selected in sequence from a standard deck. Just in case you don't know what a standard deck is, we're talking 52 cards. There are 4 suits. In a deck, there's hearts. I don't know why I'm choosing to draw them, but here we are. Diamonds, there are spades, and there are clubs. Why did I choose to do that? Spades and clubs are black cards, which is obviously why I'm coloring it in blue. And these ones are red cards. So there's 13 in each suit, and that includes ace through king, ace 2 through 10, jack, queen, king. 2 cards are selected in sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king, and assume that the king is not replaced. So we don't have to multiply anything here, because only one thing is happening. The first card was a king, and then it got thrown away. So what's the probability that the second card is a queen? Well, there's 4 queens available, and there are 51 cards left that are available. So that's a 4 out of 51. This one shows a study where researchers looked at a kid's IQ and looked at a gene. So they were trying to see if like a gene being present or not was related to IQ. And find the probability that a kid has an IQ given that the child has the gene. So since it says given that the child has the gene, all we care about looking at is this column. That's all we're worried about. And it's a high IQ, which is 33 out of 72. Let's see if I figure out the decimal for that. And remember, with probabilities, you can either answer as a percent, a reduced fraction, or as a decimal. So this would be about 0.5458. Okay. Example 8. This one you can go ahead and try. So pause the video right now and try to do example 8. Pause, pause, pause. Okay, I'm assuming that you paused and you came back. Find the probability that a child does not have the gene given that the child has a normal IQ. So this time we're only looking at the normal IQ row, and they do not have the gene. That would be 11 people in that row do not have the gene out of 50. Unusual probability is officially labeled as less than 5%. Okay, independent events. Independent events are 2 events or more that do not affect each other. Okay. For example, rolling a die twice. If I roll a die the first time and I get a 1, and if I roll the die a second time, because I got that 1 on the first die doesn't mean that I'm going to get another 1 or that I won't get a 1 now. It has nothing to do with the other one. That's why they're independent. Dependent events are 2 events that are related to each other. Like me opening a can of cat food and my cat running in the room. I say that because she is currently eating food underneath me. So, you know, maybe you can hear little crunches. That's her. When I open a can of cat food, my cat always runs into the room. So that is dependent. All right, for example 9, you are going to go ahead and try right now to label each one as independent or dependent. Go ahead and pause the deck or pause the video. Getting tired now. If I wasn't tired enough on that one problem, then I messed up like 8 times. Okay, pause the video. Try it. Okay, selecting a king from a standard deck, not replacing it, and then selecting a queen from the deck. These are dependent events, specifically because you did not replace the king. That changed how many options we had left to draw from. That's why it's dependent. Tossing a coin and getting a heads, and then rolling a 6-sided die and obtaining a 6. Those are not related to each other, so that's independent. Driving over 85 miles per hour and getting into a car accident. Now, that doesn't mean that if you drive over 85 miles per hour, you're automatically going to get into a car accident. Lots of people do not get into car accidents, but I bet if you looked at the probability that you would find that out of people who are not race car drivers, that if they're going over 85 miles an hour, they've got a higher probability of getting into a car accident. That's what makes it dependent. Multiplication rule says the probability of A and B is the probability of A times, that's times multiplied, the probability of A, so the probability of A multiplied by the probability of B given that A already happened. So it's basically A times B, but B is like conditional because maybe it changed because of A happened. So for example, let's look at this one. 2 cards are being selected without replacing the first card from a standard deck of 52 playing cards. Find the probability of selecting a king and then selecting a queen. Okay, so we have 4 kings. That's my king spot. 4 kings out of 52 cards. And then we multiply that, because it's an and, by how many queens there are. That's 4 out of 51 now, because we did not replace the card. So when you multiply fractions, you multiply the tops together, which is 16 over 52 times 51. Handy calculator tells me that's 2,652. Now I'm going to divide those two, because I can see that it's something that I should be reducing, and I don't want to reduce it. And I got 0.006.